Hello and welcome to this JunoViewer webinar number 6, an introduction to the SQL view for JunoViewer users. My name is Ravi Kiran. I'm one of the team members here at Lonrix, where our mission is to help engineers make informed decisions. This webinar is designed to be very basic rundown of the SQL view in JunoViewer. I'm sure basic SQL be familiar to many of our users. My intention to give you a hands-on experience in writing select queries and showing you how to directly access the raw data in your account. Let's get started. Okay, first things first, some housekeeping points. Please add questions or comments in Zoom Q&A area. If you get stuck or something does not work, raise your hand in Zoom. To follow the webinar and do hands-on practice, you will need to use split screens or exit full screen in your Zoom window. If you ask for a login, please log into JunoViewer now and be ready with example SQL queries we have shared today. Right. In this webinar, I'll be discussing 3 points, which is what is SQL, a very quick one, and SQL statement query structure, just to give you a bit of background on the select statements in SQL, and SQL view page demonstration in JunoViewer with examples, followed by Q&A. So what is SQL? SQL stands for Structured Query Language. And the aim of this particular language is to communicate with databases with the data stored in tables and columns, and perform tasks or functions to retrieve, add, update, and delete data in your tables. But of course, today we'll be focusing a tiny percentage of retrieval part of SQL. And if you are interested to know more and learn more in SQL, then I strongly recommend you check out w3schools.com/SQL. Just a quick disclaimer, SQL view in JunoViewer does not support all features of SQL statements due to security reasons. However, it supports enough for you to get access to your data in many ways. Now, SQL query structure. So in any SQL select query structure, there's always 5 important parts. The first one is the command, which is select. So you're instructing the database that I wanted to select data, and followed by the list of columns that you're interested to retrieve from the database. And another command, which is from, which is followed by the table name and condition. Let me quickly show you how this syntactical structure will look like as an example. So here you can see I've got the command select, and I've given my column names here. I'm interested to retrieve 4 columns, which is section, location, measure date. In our case, it is a survey date, and lane mean rut column from the routing table. And I wanted to filter, and meaning add a condition to my output selection, so that I can narrow down the total selection by giving a condition. And this condition here is where section equal to 3329. Just to give you a bit more background and also information about our examples that we're going to go very soon. In any select query, if you see a word with capital letters, so that's a command. That's a command to the SQL server. And the words which are starting from a small letter, those are the column names of the table. And then the word which starts with capital letter, that's the table name. Just keep this in mind. All right, so now let's jump on to JunoViewer and see how SQL works in the SQL view. If you have provided with the sample queries, please make sure that the file is opened. And I will be working through those examples that were supplied. So once you open your JunoViewer, go to Analyze menu, and the last menu is SQL View. Click on that. and that opens the SQL view feature in JunoViewer. Let me walk you through this page quickly before we go on to the SQL statements. So this page has two sections. The first section shows tables and columns, and the second one is to write direct SQL queries. In the first section, the first table comprises of the tables in your database, basically the tables which you have defined. And the first column, the table names, this is the column that we use in our query. When we write the SQL queries, please don't use the label. Label is just an additional information on the table name. So use the table name, and when you click on a table name, so next grid will be populated with the columns in the selected table and also associated data types. So this is very handy to copy and paste in the SQL box. Okay, let me write a quick SQL or SQL select command. Say select star from texture. So I'll just make it capital because that's the table name, and click on retrieve data. So once I click on retrieve data, so it's giving me a bit of information here. So the information is the select command is returned 1.34 plus million 1.34 million records, but only 2,000 records, or the top 2,000 records, are displayed in the grid because there's no use that we display all those records. But when you download, it downloads top 800,000 records in Excel. But if you want all the data, you can let us know, and we should be able to give you the data in the format that you want. And another feature of this area is when you write a complex query, you should be able to save that query, and it saves. And next time you don't have to write the whole query, you can click on retrieve query and you should be able to see the query that was saved previously. For example, if I'm interested in this query, I click here and that query is automatically pasted for me. All right, so I'll just change this to this one so that this query matches with the output. The people who have requested for the login, so we sent you this file already, and I'll go through these examples now. So and we have done this already, but let me just explain this again. Select is a command. Star stands for all columns from the table name, which is texture table here. So I've just given you an example here, but I strongly recommend that when you write select queries, it's always best practice to use column names instead of star, because when you use column names, you can only aim for the columns and the data that you're interested in rather than the entire table. Okay, so I'm now jumping on to my second example. So in this case, I'm instructing the database that I want to retrieve 6 columns, which is section ID, lane, location from location to measure date, which is survey date in this case, and lane mean texture columns from the texture table. So I'll copy this and paste in my query window and click retrieve. So of course, I expect 1.34 million records. Yes, that's 1.34 million records. But the difference is it only displayed the 6 columns that I'm interested in. Okay, so in this case, we are retrieving all rows, but of course, only 6 columns. So what if we wanted to filter our data on a condition? So in this case, I've used example, a section with the section ID is 3367. Okay, so then I separate the select statement from a condition or the command called where. So after the the text after where is treated as the condition. So here, again, to explain, I'm instructing the database, select these 6 columns from texture table where section ID equal to 3367. So I'll copy this and see what happens. And paste it in here. Okay, so there's 8,350 records available in this section 3367. So you can see here, there's a section ID, lane, location from location to, measure date, and the lane mean texture data is populated. So I haven't really used the download data function yet, but let me show you what happens when I click on this. Okay, so it's downloaded all those 8,000 records. Zoom in a little bit. So these are the columns that I'm interested in, and I'll go in. So you can see it's 8,350 records. Okay, to move on. So this is another way of, or another example that I'm moving on. And the aim of this example is to find records from the recent survey. So of course, to find recent survey, we need to know how many surveys that's available in the database if I'm new and exploring the data first time. So for that, I wanted to know what are the unique survey dates available in texture table. And for that, I use a command called distinct, and it'll pick up all distinct or unique dates available in this column from this table. Copy and paste. Telling me there are 192 distinct or unique dates available, but you can see here the dates are all over the show. So the best way for me to know the latest date is, and I want to sort the result in descending order so that the recent date will be on top. So for that, I use command order by mes date, which is the column or the data that I'm interested in, and followed by another command called DESC. So DESC stands for descending order. If I don't give DESC, by default, it orders the data in ascending order. Okay, let's see what happens. So now you can see that all this data is sorted in descending order. And sorry, just to look at these dates, it appears to me that after 10th Jan 2019, again, the survey started on, around 25th November 2019, and that carried until 8 March 2020. So if I just think about it's usually annual survey, so the recent survey might have started on the 25th of November 2019. So I use this date for my query. So we have done this already, order by, and here just modified this query. Instead of section ID, I'm asking the database to return all data from texture table where the date is greater than or equal to 25th November 2019. And just keep one important thing in mind. For dates and text values, those needs to be included in single quotations. For numbers, it can be direct without single, numbers should be without single quotations, but for dates and text, you have to include single quotations, otherwise you may get error. Okay, I'll copy and paste this one here. So again, select the 6 columns from the texture table where measure date is greater than or equal to 25th November 2019. Okay, so this returned 4,247 records. So that's all texture data from the recent survey. Okay, so to move on, okay, that's all good, but what if I want only for one section? So I want recent or the latest survey data for a single section. But at the same time, I want the results to be sorted by lane and location from. So I want the results to be sorted based on the location on the road. So here, select column names from the texture table where a measure date is greater than or equal to 25th November 2019 and section ID equal to 3367. That's the section that I'm interested in. So whenever we have multiple conditions that we wanted to add, then we add them with AND. If we want those two conditions to be included to narrow down the result, but if you want either of that data, either of those conditions to be satisfied, then you use OR. So in this case, I've used AND, and again ordered by lane and location from. I'll explain what happens when you have two columns ordered by when we see the results. Okay, so here we can see that it's ordered by lane, which is L1, and also location from 1410, 1420, and so forth. So I'll just scroll down a little bit so that I can show you. So the L1 ended at 5,210, and then again R1 started from 1410 until 5,210. So this works exactly like Excel. So the first column sort orders it first, and then the remaining will be ordered in that particular set. Okay, so this is with where clause with end condition and also ordered by two columns. And you can apply ascending and descending on both columns or one column depending on your requirement. Okay, so I'll move on to my last set of examples. And these examples are basically for aggregating your results. And this, in our real scenarios, it also helps to find some anomalies. For example, some crazy values or values which are lower than the minimum or minimum allowed values or maximum than allowed values. So let me explain this query first. So here, the two things that I have added as part of this example. Number one, I've used an implicit function of SQL called max, and also another function min. So max stands for maximum value and min stands for minimum value. And because I want to get maximum and minimum both values on the same column or the same set of data, I want to differentiate what is maximum value and what's the minimum value when I see like a table. So when we add as and a text or column name, this will be treated as pseudo column name. So you can enter whatever you like here. And on the output result, this column name will be used instead of the original column name or no column name. So here I'm calling it max lane mean texture for the max value. For the min value or minimum value, I've just given column name min lane mean texture from the texture table. Okay, so I'm pasting it here. So it quickly scanned all those 1.34 million records and found 5.7450 is the maximum lane mean texture value, and 0.16 is the minimum value. So by quickly look at this, you should be able to find out whether it's within the limits of the expected values or it's completely out of the value, so that you can go and interrogate your data. And this is a very quick way of finding anomalies in your data. Okay, so my next example on this aggregate data points, I have added two features here. Number one, apart from max and min, I've also added three more aggregate functions. In this case, AVG stands for average, standard deviation, and count, just a standard count. But I want all these five aggregate values not on the entire table, but I want that to be calculated on each section or the data points in each section. So I'm instructing the database. This is another command called group by section ID, because I want to relate this output with each section ID. So I'm instructing the database to show me section ID as well as part of the output. So what it does is it takes lane mean texture values of each section and calculates maximum, minimum, average, standard deviation, and count, and displays like one record for each section. Let's execute and see what we find out. Okay. There's 275 sections with data. And you can see here, of course, the section ID. And here it automatically displays only unique section IDs. It won't repeat section IDs. That's the beauty of group by command. So here, section ID and the maximum value in that particular section is 2.75, minimum is 0.52, average, standard deviation, and count. So 275 points were taken to calculate this. And you can see quickly on some of these sections are a lot of data points. So the sections probably be longer compared to the small, little data points. Basically, those sections might be shorter. Okay, so that concludes this webinar and examples. I hope it helps. Thank you for listening. And if you have special requirements or complex queries you would like to use, please send us an email to support, and we'll try our best to address them. If there are any questions, we will deal with those now.